lot of trig in calculus, or is it?
Especially Calc 2 has a lot of trig. Calc 1 just has a little. Yeah, Calc 2 is the hardest calc by far. Calc 2 is hard. Calc 1's not too bad. I mean, Calc 1's harder than pre-calc, but it's not. Calc 2 is the real bad one. All right, so cosine inverse of negative root 3 over 2. Cosine inverse of negative root 3 over 2. Now, that negative one up there, that means inverse, right? So now, we got to remember, what's an inverse function? If I said, hey, I've got an inverse toaster for Christmas, so I'll get my wife for Christmas. I don't think she'd be too happy. I don't think there is such a thing. But anyway, an inverse toaster. So what would that be? What just go along with my silly little analogy. What would an inverse toaster? I guess so, yeah. Yeah. Yeah, so what does a normal toaster do? For a normal toaster,
you put it inside.
You put in bread, and you get out toast. Put in frozen waffles, get out toast waffles, right? Input, output. Remember what inverse functions do? Reverse inputs and outputs, right? So with my inverse toaster, right, you would put in what? Toast. And you would get out, it would turn it back into bread, right? I know that's weird, but I want you to think right about the cosine inverse. What is a normal, let me just go down here, normal, regular, how about regular? Regular cosine. What does regular cosine do? You plug in an angle, like, I don't know, 30 degrees or whatever. What is the cosine of 30 degrees? It's root 3 over 2 on the unit circle, right? So you put in an angle, right? That's where you plug stuff in, like plugging in bread, and you get out an answer. You with me? That's a normal cosine function, or sine or tangent or any of them, right? Normal trig function, you plug in an angle, you get out an answer. That angle could be radians or degrees or whatever, but it's an amount of an opening between two lines, what we call an angle, right? You can put in, pi over 6, same thing, whatever. And you put in an angle, get out an answer. Put in an angle, get out an answer. Normal cosine. So what is inverse? Sine, cosine, tangent. It's going to reverse in and out, right? That's what inverse functions always do. They reverse in and out. So therefore, I'm putting in, what am I putting in? That's what I'm putting in, and over here's what I'm going to get out. You're putting in an answer then,
And you get out
getting out an angle. You with me? I want to make sure we're really crystal clear on that. It's the fundamental operation that's happening for inverse trig functions. You plug in answers, get out angles, It reverses inputs and outputs. Okay.
It goes from radians to degrees, right? That would be the technicality. From radians, negative 3 over 2 is a radian.
No. Radian is an angle. This is an answer. This is neither radian nor angle. This is an answer, right? You can put in either one of these, and you'll get out root 3 over 2.
Because when I input cosine inverse of negative 3 pi over 2, and I don't change it from degrees to radians.
Negative root 3 over 2?
Negative square root of 3 over 2.
Right.
I get 2.61.
Right, you get a radian answer.
And I have to change it to degrees.
To get a degree
It gives
answer.
me 150.
Right. So those are the same thing.
Okay.
It's giving you, yeah. So here, let me talk more about that. Let me bring up the unit. So you guys have the unit circle?
Yeah.
Gonna definitely want it. It is your best friend on this trig stuff. Where is the unit circle? There it is. I think is that it? Yeah. All right, so there's the unit circle. Let's definitely use that. So this unit, so you can have that. Does everybody have that? Anybody want a unit circle? Anybody got this? Here, I'll pass this around. Pass this around. If you don't have one, go and grab one. I got extras.
I gotta have really long arms for that.
So unit circle, use this. This is going to be more helpful than your calculator, and this will be on the non-calculator part of the final exam. We're on final exam material now. This is the final. This is not on the exam we take Monday, Tuesday. So, all right. So how do we do it? We're trying to answer the question. It's number 1. It's saying cosine inverse of negative root 3 over 2. So remember, that's the answer, and we want to know what angle produces that answer, right? You put in an answer, get out an angle for inverse. Okay. So you tell me, look at the picture. Where do you see an answer of negative root 3 over 2?
Right there at 150 degrees. figured either.
Remember, cosine is the first one, sine is the second one.
Right.
So right here
And 210.
and right here. Yeah, 150, 210, or radians, 5 pi over 6, 7 pi over 6. So, Luis, is that making a little more sense now? So, these are both angles. 5 pi over 6 and 150 are two ways to say this amount of opening.
We wouldn't call 5 pi over 6 degrees, right? We would call them 5 pi over 6 radians.
Right. Yeah, so from this line to this line, that amount of opening is 150 degrees in the degree system. What's a degree system? All the way around is 360. Why did we make up that system with all the way around being 360? Did I talk about that already?
Circle has to do with the pi, right?
Because all circle will be 360 no matter what.
Yeah, because all the way around a circle is 360. But why? You know, they just made that up. They just made that up. They said, hey, all the way around, we're going to call that 360. And then everything else comes from that. That's why a quarter of that's 90, 1/4 of 360. Why? Why did they make such a weird number as 360? Why didn't they say all the way around is a nice even 100?
Because that goes to 0, right? It ends back at 0.
Well, it is 0 because they made it that way.
Yeah.
That's not why they made it that way. It's 0 because they made it that way. It's reverse. No, they just made that up. Are you guys tracking with me? They made that up. They just said, hey, all the way around, they could have called it a nice even 100 or a nice even 1,000. Why'd they do 360?
That's what it is. One revolution.
It's historical. What was happening? What's about around in 360?
A pizza.
Sun.
I mean, yeah, are orbiting the sun, right?
Earth
It was
is still flat.
Yeah, right. It's back, they first did angles when they were using navigation by the stars. That's when they were first using angles in real life applications. And the close estimate to how long we circled the sun was 360 days at that point. That was as close as they estimated. We now know it's closer to 365. Anyway, that's where they just made it up. I just want you to know they made it up. The angle system is just made up. They just said, hey, all the way around is going to be 360 because that's what it seems like we go around the earth, they thought
So
at that time. They could have made it 100. They could have made it 1,000. They just made it up. Well, then the other system, so therefore when I say this is 150, that's because it's almost halfway around, which would be 180. You know, it's just the amount of opening between those two lines. That's what an angle is. It's an amount of opening, right? If I open the door a certain angle, it's the amount of opening. That's what an angle is. So then there's another system called radians. And so radians, they made that all the way around 2 pi. And so 5 pi over 6 is the same amount of opening in the radian system as 150 degrees is in the degree system. They're just the amount of opening. And they both lead to the answer, cosine negative root 3 over 2.
That's another system.
Yeah, that's the answer. Now, by the way, what is the radian? You guys have had trig. What is the radian system? What's that?
I gotta go back to Little Caesar.
Was it by
Look it up.
the Mayans or anything like that?
I have no idea the history there. But
Egyptians?
2 pi, it's literally the arc length. So in other words, all the way around a unit circle of radius 1 is 2 pi length. Like if you could measure a tape, if you take a tape measure, if you had a circle of radius 1 foot, let's say, 1 foot, and you put a tape measure all the way around, this would come out 2 pi, 2 times 3.14, you know, goes on and on, 6.28, about 6.28 feet, or if you did 1 inch, it'd be 6.28 inches, or you did 1 yard, it'd be, you know, a circle of 1 yard, it'd be 6.28 yards around. Why? Because what's the circumference of a circle? Remember the formula for the circumference of a circle? How far around the outer edge? It's 2 pi r. And if the radius is 1, it's 2 pi. So that's all they did with the radian system. They just said, hey, let's just go the arc length. So when we say it's 5 pi over 6, they mean how long this arc is. From here to here, between the two lines, the arc length, for if that's a radius 1 circle, will be 5 pi over 6. That's all the radian system is arc length. That's all it's doing. So anyway, probably too much of the story, I don't know. So there are the two systems, right? Angle is degrees made up, 360s all the way. Radians is arc length, another made up system. Either way, indicating how much of an opening between two lines, what we call an angle. And then the trig system, yeah, the cosine is negative root 3 over 2, and the cosine is negative root 3 over 2. That's the answer for either the 150, 5 pi over 6, or the 210, 7 pi over 6. So we have two answers here, don't we? And by the way, they want the radians. They always want the radians in this, you know, this point forward. They're mostly, not always, but usually going to want radians. 5 pi over 6, 7 pi over 6, those are our two answers. You guys have your calculators?
Yep.
Want to hit inverse cosine of negative root 3 over 2? It won't give you both answers.
It'll only give me one.
It only gives you one.
No, it'll give me the one that.
It'll give you the angle 5 pi over 6 or 150 degrees, depending on what mode you're in. If you're in degree mode, it'll tell you 150. If you're in radian mode, it'll tell you 5 pi over 6, which is like about 5 times a half, about 2.5, 2.6 probably. Is that what it is?
So if I'm finding the
So my point is, real quick, I'll let you finish. But my point is, you don't want to use your calculator. It's not going to give you all the answers. Even if I let you use the calculator in the test, you'd still want the unit circle. It'll give you both the answers, not your calculator. Barbara, what do you want to say?
so when I'm finding the opposite, what do you call this again? Cosine negative.
Cosine inverse, the inverse
The
cosine?
inverse function.
Yeah.
I want to stay in radian if we were using calculator.
Yeah, you want to stay in radian, but that's the other problem. They're going to ask you for a pi answer, and your calculator won't give you a pi answer. There's all kinds of problems with using the calculator on these. You really need to use the unit circle for several reasons.
We're constantly going back and forth in 3 systems then, right?
Well, we'll probably just do radian and answer. We won't mess with angles.
Okay.
I mean, what was that? What was it? Degrees. Yeah. All right. So does everybody see that? Your calculator only gives you one of the. It only gives you this answer. It doesn't tell you about this one down here. For a longer story, and I've done enough stories today. Let's just move. Let's move ahead. Maybe next week I'll tell you the deeper story about why the calculator only gives one answer. It has to do with. See, I want to say it, huh? No, let's move on. On we go.
Are you picky
2
about
answers.
if we put radian after the pi?
What's that?
Are you picky about us writing the word rad?
Oh no.
Okay.
5 pi over 6, 7 pi. Okay. So our answers when we did that, we saw in the calculator 7 pi over 6 or 5 pi over 6, right? Those are the 2 answers. It says type your exact answer. That's why you can't just do the decimal thing your calculator gives you, using a pi. So now we should be able to roll and just crank these out. We can do 13 of these in 5 minutes. No. So we'll do a couple, though. So now you've heard the whole story. I wasn't going to give that whole story. Sine inverse of root 2 over 2. So remember, this is an answer, and you're looking for an angle. So go to the unit circle.
Pi 4 or 3 pi?
So just look, and remember, you're only going to give one of the 2 answers that you'll see there. That's the wrong thing I just
It'll
grabbed.
be quadrant 1. So pi.
Where is that thing? Did you find it on your unit circle?
Yep.
I can't get my unit circle. There we go. So what are we trying to do? Sine inverse of root 2 over 2?
Yeah.
Is that what it is? Yeah. Okay, so where sine, it's cosine sine. So it's cosine sine's right here, huh?
Right.
So now there's going to be another one, but I only take answers from here. No, wrong. Yeah.
The other way.
Well, basically, this is positive, huh?
Yeah.
This is positive. So positive stuff's always first quadrant for any of them. Positive stuff is always first quadrant. It's only when they're negative that you got to say, okay, which one's their negative? Cosine it would be that one. Sine inverse and tangent inverse would be the 4th quadrant, right? So we're just looking in the first quadrant. I don't need to look anywhere else. There it is, 45 degrees, but they want radians, pi over 4. Done. So the answer is pi over 4, we're done.
Wait, we're gonna need to have this, or we need to draw it?
You need to put it on your questions I can answer on that. Making sense now? So now they're pretty predictable, right? So let's try this one. So cosine inverse of 0. Try that one. Remember, this is an answer, and you're looking for an angle. So go to the unit circle.
Pi half.
So where's the cosine 0?
Right there. Up
Pi
the top.
half.
So it's always cosine first, sine, so that's not right. Oh, right here. Cosine, remember, it's always cosine first, then sine. So cosine 0 right there, pi over 2. We good there?
Oh my god, it's so easy.
Now it's easy, huh?
Crazy, yeah.
So where are we? Here. So it's a pi over 2.
You should give more 15-minute stories, Mr. Grant. I'll get it all done.
That one's got to be plugged into the tangent because there's nothing else there.
Good. So
Tangent inverse. I'll put parentheses, but it's not required. So they just want you to use your calculator, get a decimal, round to the 2 places, hundredth. Just make sure you can do that. Oh, you got to be in radian mode though. Make sure you put yourself in radian. I'm in degree right now.
4, 8.
They're asking for radian mode. Tangent inverse of 11. I'm getting 1.48
Yep.
radians. You able to get that? If you have any trouble, come up. I'll be glad to help you. That's calculator.
Wait, how do I convert the other way? How do I convert the number into an angle?
set it equal to what?
This is an angle. No, I'm sorry, I'm wrong. Oh yeah, that is an angle. This is an angle. This is a radian angle.
Yeah. You're talking about going back to 180, right?
Yeah.
To degrees, right?
Oh, go back to degrees?
Converting from.
Yeah, you would. If they're not going to ask us to do that.
Oh, okay. On the test, right?
But probably on the test. No, I'm kidding. Yeah, no, it's just like. So tangent inverse of minus 6.4 radians. Hit the buttons on your calculator. Tangent inverse minus 6.4. I'm getting minus 1.42. Remember to use the right negative. Remember the calculator flips out if you use the subtraction key instead of the negative. So that's a radian angle. That's what that is.
Well.
All right, Will.